Okay, so in this video, we're going to start looking at some of the questions that you guys had trouble with in the class, and we're going to begin with chapter 15, problem number 6. Okay, so what it says is that t equal to 0, you've been told that the position of the object is xi, the velocity is vi, and the acceleration is ai. So all this has been given, and the first question is to figure out, to show, along with the fact that the angular frequency is omega, and you've been told to show that the x as a function of time is given by this relationship, that x is equal to xi cosine omega t plus vi times vi over omega sine omega t. Okay, so the way we're going to answer this is we're going to begin by saying, okay, if you have an object if you have a differential equation that looks like this, okay, we already know that the general solution to this differential equation could be written in the form of let's say alpha, instead of alpha let me use say C1 cosine of omega t, where C1 is some constant, plus C2 another constant times sine of omega t. Okay, because you've been told that the angular frequency is omega. So we know that this is what the equation looks like. So now it becomes a problem of simply finding C1 and C2 given the initial condition. So now what you've been told that at t equal to 0, okay, x is equal to xi. So let's plug in time equal to 0 on this equation. So at x equal to 0, we get C1 times cosine of 0 plus C2 times sine of 0, and we've been told that this is equal to xi. Now cosine of 0 is 1 and sine of 0 is 0. So this implies that C1 is equal to xi. So we get C1. Okay. Now let's try to figure out what C2 is. You've also been told that V at 0 is equal to Vi. So now let's first find what V is as a function of time. Okay. And this gives us V as a function of time would be equal to C1 times omega, okay, with a negative sign, times sine omega t plus C2 omega times cosine omega t. Okay. Now let's plug in the value. So V of 0 would be equal to negative C1 omega times sine of 0 plus C2 omega times cosine of 0. Okay, and we've been told that this is equal to Vi. So once again, the first term here is 0. This cosine of 0 is 1. So this implies that C2 omega is equal to Vi. And so this implies that C2 is equal to Vi divided by omega. So now that we know all the stuff, we can go back into x of t, and now C1 is simply equal to what is it? Is equal to xi. So we have xi cosine of omega t plus Vi over omega sine of omega t. Okay, so this gives us the first equation. The next thing it wants us to show is that, okay, so we want to show that the velocity is this. Now once we get the acceleration, the velocity is very simple. Okay, V of t from the, once you get the position as a function of time, we can differentiate that and get the velocity. It is equal to, so we have to show that. Okay, so we want to show this. So dx by dt is equal to, if we differentiate this, we get negative xi omega sine omega t plus the second term is Vi over omega, and when we differentiate sine omega t, we get an omega times cosine omega t. So here you see the omegas cancel out, and then we essentially get the expression that we are looking at. Okay, so that's part B of the question, or rather the second part of part A. Okay, so part B of the question says that if A is the amplitude, then we need to show that V squared minus AX is equal to Vi squared minus AIXI, which happens to be equal to omega squared times A squared, not A2, my bad. Omega squared times A squared. Okay, so what we'll do is basically, we need to first find A, we know the expressions for a, x, and v. Let's find a as a function of time, and this is simply going to be equal to dv by dt. And if we, since we know velocity already, we can write this as negative xi omega square sine, not sine, the derivative of sine is going to be equal to cosine of omega t, okay, plus we have a vi here, so it will be vi times omega times sine omega t, but we're going to have a negative sign, so it will be minus vi times all this, okay. So this gives us the value of these terms here. So this gives us the acceleration. Okay, now what we are going to do is that we can first evaluate this v squared minus a times x, and what this is let us take the v term, which happens to be negative xi omega sine omega t, okay, plus vi cosine omega t, okay, the whole square, and then we will need minus a, which happens to be xi omega square cosine omega t, minus minus vi omega sine omega t, and multiplied by x, which is xi cosine omega t, plus vi over omega sine omega t. Great, so let's multiply all this out. Okay, the first term is basically a plus b the whole square, okay, so, or a minus b the whole square, so this is going to end up being xi square omega square sine squared omega t plus 2, or not plus, it will be a minus, it will be minus 2 xi omega sine omega t cosine omega t, and there's also a vi term here, so let's squeeze in a vi here, so it will be xi omega vi, okay, plus vi squared cosine squared omega t. So that's the square of the first term, and the second one gives me minus, okay, so I'm going to leave everything in here, so in fact the minus can come out, I can factor the minus out of this, write it as plus, okay, and I get xi omega square times xi, so I get xi square omega square cosine square omega t, okay, then the first term times the last gives me plus xi, one of the omega square will cancel the omega in the denominator, omega vi cosine omega t sine omega t, okay, then I have a plus, again vi omega times xi sine omega t cosine omega t, plus vi square sine square omega t, okay, I actually don't need parentheses here, so let's not have them, okay, great. Now let's try to combine terms together, okay. The first thing is that you'll see that this term and this term, okay, are similar. There's a sine square and this is cosine square, the coefficients are the same, so the first term I'm going to write as simply xi square times omega square, okay, because the cosine square plus sine square is equal to 1. Great. Now the second term, this is this 2xi omega, all this, now this will cancel this and this, and then we're left with the third term, which is equal to plus vi square, okay. So those are the terms that we are left with, but we have a problem. Okay, so in part B of the question, we want to show that v square minus ax is equal to vi square minus aixi, which is also equal to omega square times a square, where a is the amplitude, okay. So So let's begin by showing that the first two terms are equal. Okay, now in order to achieve this, first we need to figure out what a as a function of t is. And in order to do this, we're going to differentiate v, which is up here, and the derivative of this is going to be negative xi times omega square cosine omega t, okay, plus, or rather there's going to be a negative sign because the derivative of cosine is minus, so it will be minus vi omega sine omega t. Great. So now we have the terms for v, a and x. Okay, so let us evaluate v squared minus ax now. So v squared minus ax is going to be equal to v, which is all this, negative xi omega sine omega t plus vi cosine omega t, the whole square, okay, minus a, which happens to be negative of xi omega squared cosine omega t negative vi omega sine omega t multiplied by x, which is xi times cosine omega t plus vi over omega sine omega t. Great. Now if you look at this, okay, the negative sign can be distributed inside, and we can write this as positive, and then everything is positive. Okay, so I can distribute that. Now also if you look at the second term is simply if I multiply and divide by omega. Okay, this is the second term and the first term essentially are the same except for a factor of omega. Okay, so we actually don't need to worry about it. So let's do this. Let's square the first term out. Okay, and what we have is this. We have, let me do this. Let me show you something. So the first term, I'm going to rewrite the first term, sine omega t plus vi cosine omega t square. Okay, and the second term, you see what I'll do is I'll multiply the second term here by omega. So this will be omega and then divide by omega, and so I get xi omega cosine omega t plus vi sine omega t in the numerator, and the denominator is omega. But I can move this omega to this side, and you see I have the two terms here which I can cancel out in the omegas. Okay, so the second term is simply plus xi omega cosine omega t plus vi sine omega t the whole square. Okay, so we get that. So now let's square everything out and see what happens. Okay, a lot of things you'll see will cancel out. So the square of the first term gives me xi square omega square sine square omega t minus 2 xi omega vi sine omega t cosine omega t plus vi square cosine square omega t. Now the second term ends up becoming xi square omega square cosine square omega t plus 2 xi omega vi cosine omega t sine omega t plus vi square sine square omega t. Okay, now here you see the second term can be cancelled out, and then the first term has a cosine square and a sine square and then the same coefficient. So this becomes simply xi square omega square. The last term also has the same property, and this becomes simply vi square. So what we've shown is that v square minus ax is equal to vi square plus xi square omega square. Okay, now we want to show that vi square minus aixi is also equal to all this, because then we can show that these two are equal to each other. Now in order to achieve this, essentially all we need to do is find ai. If you look at the expression for ai is equal to, if you look here, ai happens to be equal to simply this, a evaluated at 0. okay, is equal to a evaluated at 0, and which happens to be equal to, simply if I put 0 here, the first term becomes 1, the second term, the cosine omega t here will give me 1, this will become 0, and so all I'm left with is negative xi omega square. Okay, so this implies that vi square minus ai xi is simply equal to vi square minus ai, which happens to be minus xi omega square times xi, which is equal to vi square plus xi square omega square. And if you see, this term and this term are identical, and we get the answer. Okay, so we've shown that those two things are the same. Now we want to show one more thing, which is that all this b square minus ax is also equal to omega square a square. This is the last thing that we would like to show. Okay, now the answer to this is fairly straightforward. Here's what we're going to do. We're going to go back to our definition of the amplitude itself. Okay, and when I write the function, what's it called, when I write x as equal to xi cosine omega t plus vi divided by omega sine omega t, when I do this, okay, I can rewrite this in the form a cosine omega t plus phi. Now this is a simple trigonometric transformation, and in order to achieve this, what you do is you take the coefficients of each of these things and rewrite that as, you basically multiply and divide it by square root of xi square plus vi square over omega square. Okay, and then you have xi over square root of xi square plus vi square over omega square times cosine omega t plus vi over omega divided by square root of xi square plus vi square over omega square times sine omega t. Now if I set if xi over square root of xi square plus vi square over omega square, okay, is equal to cosine of phi, then we know that this has to be equal to sine of phi. Okay, and you can show all this by drawing a triangle here, where the sides of the triangle are this angle is phi, this is xi, this is the adjacent opposite is vi over omega, and the hypotenuse is xi square plus vi square over omega square. Okay, so we get all this, and so I can write x now is equal to square root of xi square plus vi square over omega square times cosine of omega t minus phi. Now here the first term is simply the amplitude. Okay, and so now we see that a square times omega square, if I were to square this, then I end up getting xi square plus vi square over omega square multiplied by omega square, and this gives us xi square omega square plus vi square, which is exactly what we needed to prove. Okay, so that is the problem number 6. It's involved lots of calculations to be done, but if you go through the process, you see that it's fairly straightforward.